So good morning or good afternoon, depending where you are. My name is Eric Charton. I work at National Bank of Canada. I lead an AI team who is in charge of various applications of artificial intelligence at the bank. And today I would like to speak about some application we have to handle customer satisfaction. So on this slide, you have a set of verbatims with the source and the distribution of those verbatim across time. So we collect that kind of data from any channel that are available in the organization. So that can come from emails, voice conversations with speech-to-text transcriptions. It can come from polls. We can have some extraction from Google Place, from various API. In those small text, or a little bit bigger sometimes, what is interesting is you have some way to study what is in the mind of your customer, knowing what kind of problem he encounter, and that is what is interesting us. So we try to build some applications that will go inside those verbatims using some topics of interest. In this example, it can be the name of credit card, MasterCard, for example, but it can also be some topic about payment, about troubles, and we want to detect the opinion of the users and investigate this. The problem to solve is that text analytic solutions that are on the market, and even if it can be surprising, is that most of the solutions are keyword-based for topic detections. Many solutions are claimed to be machine learning based, but in fact, when you look inside, it's keyword-based. Keyword-based is a very old technology. It's something that was created in the 60s with the information retrieval field of research. And when you go to a keyword-based analytics, you face a lot of problems because this technology is not adapted for fine topic classification for two main reasons. The first reason is that in real life applications, the topic you want to detect are unbalanced. What we mean by unbalanced is that some of the topic will represent 40% of what you are looking for, and some other just represent 1% or sometimes less. And this is something that is very difficult to capture using keywords and even using machine learning sometimes. And the second question that is solved by machine learning application, but is not or difficult to solve with keyword-based solution, is that the word sense disambiguation problem. This problem that I will depict in some few slides that follows create noise in keyword-based system. And when you have this kind of noise, you will have, for example, for the topics that have a very low representation, you will have a high percentage of error. And if you are looking for the verbatims that are related to a credit card, for example, and you got something about phone calls or whatever, it's difficult to use the data to collect some good insights. What is the word sense disambiguation problem? The ambiguity of the language is the key. I take here a short example. Apple price is to watch. We know we have to look at the price of something, but this can be some very, very different things. It can be people who work with commodities, with fruits. They want to know the price of the apple for whatever reason. Or it can be also a stock trader on banking environment, someone who have a stock account, who want to know the price a stock ticker. So we see with this very simple example that the word sense ambiguity is something that is everywhere in the language. And in the banking context, it can be a very big issue if you are not able to discriminate between the various information that you want to extract. In this example, that is in French, National Bank of Canada have a lot of customers who are French-speaking people. I gave two examples. Mon compte de prêt doit être suspendu. Et je ne suis pas prêt à fermer ce compte. Meaning, for the first one, my loan account need to be suspended. It was a very important issue during the COVID. And for the second sentence, I am not ready to suspend my loan. So we see that in those two short sentences, you have the most preeminent keyword that are account and loan that are exactly the same and have completely opposite meaning. So if you want to get good insight from your verbatims, you need to have a solution that goes beyond the just keyword-based information extraction. To give you an example, and especially on how we can measure this bias and that kind of trouble, if we imagine we have a customer feedback stream of comments, and I put in this one 4 classes or topics. Those topics are various, not meaningful information, credit cards, subsidiaries, and mobile app. Those are the 4 topics. But we see that what is called unbalanced data set, those 4 topics have a very different proportion in the corpora. And the reaction of the classifier or the system that is in charge of detecting those topics, and those come from real life application, will give you an accuracy that is very good on the first class, the class that is the less interesting one. Just to remind you, the accuracy is the percentage of good answer. It's equivalent to the precision. Lower on credit cards, lower 30% accuracy on the subsidiaries topic, and lower on mobile application. So in this 4-class system, you have a global accuracy of 80%. So if you have a vendor that is presenting you the system, he will tell you, oh, my system is 80% accurate. But in fact, when you look at it for mobile application comments, 8 on 10 verbatims are not properly classified, meaning 80% of error. And with most vendors, when you get presentation of a product, they give you the accuracy globally, but they never go deeper in the class, and that's where the problem lies. To try to answer to this question, we decided to conduct an experiments using a standard corpora to evaluate some new techniques. By standard corpora, I mean a corpus of text scientifically tested before the period where deep learning was massively deployed in natural language classification. And we want to apply to this corpus where we have some measure coming from 10 years ago or before, the new techniques, embeddings, and the convolutional networks. What we want to know is the neural networks can handle the problem of unbalanced class and of ambiguity, of course, and if the new techniques can improve the topic detection problem. We choose to use a data set of French cooking recipes. It was very interesting evaluation campaign with 2 tasks. First, classifying the level of difficulty, and second, classifying the meal tip. What is interesting in those 2 tasks is that first the class are unbalanced, but also there is big variations between the verbatims that are to be classified. because this is a corpus that comes from corporate collective tagging websites, and many people can have a very different opinion of what is a starter, what is a dessert, what is very easy, what is difficult. So it's a difficult task, and for this reason, it's interesting to test the technology on it. This is a real-life corpora. So there is massive ambiguities, and as you can see, for example, on the task 1, the difficult label represents just 0.6% of the whole corpora. So you are really unbalanced label. And on the second task, you have more equiprobability between the topics, but you have this difference of appreciations between what is a starter, what is a main dish, and what is a dessert that create a lot of ambiguity. So we have 2 tasks, and those 2 tasks cover what we are interested by. The previous state of the art was established in 2010. So it was classical linear classifiers, SVM, logistic regression. And we have the result on those classifiers. So the question that we want to ask is, does a deep learning classifier with embeddings like BERT and all those new techniques can outperform this state of the art? And do this classifier perform better with or without feature selection? Because one of the claims of the modern deep learning techniques, including BERT and the embedding, is that you don't need to do feature selection anymore. And this makes the construction of the system much more easier. The proposed system was to buy two models, one with the hidden layer of CNN, one other with GRU. For the embedding layers, we use the pre-trained BERT and Camembert. This is a French adaptation of BERT. And we added a linguistic submodel. These linguistic submodels extract some features, meaning that there is a selection of specific characteristics of the text. In the context of recipe, it's interesting because you can see what are the ingredients that are very interesting. And we test this linguistic submodel to see if the neural model is able by itself to detect the ambiguity, or if the linguistic feature can improve it. The experiments we conducted gave very interesting result. At the bottom, first, you see the 3 teams. So it was an evaluation campaign. So the result and the system were public. That was it. What is really interesting with these experiments. You can see the first team obtained the result that were state of the art for some years in the literature. And then if you look at the simple neural networks without linguistic features, the neural section on the top. In fact, the neural model with BERT and embeddings and reconfigured embeddings and various configuration cannot overperform a system that was made old-fashioned way with the SVM classifier and the linguistic feature. But if you add those linguistic features on the neural networks with the embeddings, you overperform in F1 measure the classical system. So that means there is an interest to use those systems, and we will have a look at how it works on the class of our experiments, because what is interesting us is to correctly classify the class that have underrepresentation. So those are the class that we use at the bank. So you have loans, successions, credit, loans, chargeback, waiting time, and all of that. So that are the topics we use. And we see that for those topics, the first column is the model without linguistic feature. We have some class that have a very low representation, like vocal box and stuff like that have literally 0. The system are not able to classify. And when we introduce the complete systems with the linguistic feature, we are able to classify all the class with acceptable results, low sometimes, but better than zero, much more better. And we have some important improvement of the performance on some others. How is it used? To finish this presentation, I will give you some screens. So we use Kibana. Kibana is the layer that's just over Elasticsearch to help to analyze some data and display it, creating some dashboard and some investigation. So we classify all the verbatim before feeding those to the Kibana system. And we add the class. So, and we give the possibility to the operators to have some insights. So see the repartition of each class, each topic, and then for each topic to go and investigate what were the verbatim and go deeper and get from this some insights. And from those data are built some reports for various aspects of the business about customer satisfaction. We build some dashboard that are ready to use and that can be directly published with the tendencies. And we have 8 dashboards like those one for retail banking, for various aspects of the banking. This is the end of the presentation. We have 2 papers that were published about that. I will give the reference. They are on the screen. One in French that was published at LREC, one in English that was published in the 2 conferences. So you can have all the elements and the source code is available. Thank you.